So number 5, I'll leave number 4 so that you can see it. Number 5, here we go. So let's go ahead and factor what we know. Okay, so here we have 2 and then x squared. So, just x squared. So x squared is the only thing that we can factor out of everything. So we have 2x squared minus x minus 6. All right, so that's what we have so far. Now what is, well, a doesn't equal 1, so we have to go ahead and factor, replace, and group. All right, so this is what we have to do when your a value does not equal 1. So we have to take our a value times our c value. So we need something that multiplies to negative 12, and it has to add to our b value, which in this case is negative 1. So it's two numbers that multiply to negative 12, and those same numbers have to add to negative 1. So go ahead and replace the middle term. All right, so this would be negative 4x plus 3x minus 6. So again, we did not change the equation. We just replaced it and expanded it, so this way we can factor by grouping. All right, we can't factor by grouping 3 terms. It's an odd number of terms, so we have to make it an even number of terms so we can group 2 and 2. All right, so I'm just going to go ahead, x squared. All right, the first two, what do they have in common that we can factor out? Well, 2 and negative 4 are both divisible by 2, so we can factor that out. They both share an x, so we can factor that out. Then what do we have left? We have x minus 2. Now, great thing with factor by grouping, x minus 2 should also be over here if it is factorable, which it is. 3 and negative 6, they're both divisible by 3. It is going to be a positive 3. All right, and that is it. So we're going to go ahead and put everything together, and I will rewrite it back on the line. So I'll write it right here so we can see it and remember it. So x minus 2 is what they both share, and then in another set of parentheses, we're going to write what we have left over, so that 2x plus 3 has its own set of parentheses. So I'm going to go ahead and erase this so I can write it on the line. Right, and then erase this part so we can graph. All right, so back here, x squared. Ooh, I forgot to write g of x equals x squared, x minus 2, 2x plus 3. All right, so that's our factored form. I'm going to go ahead and erase this. Okay, so our roots, we're going to set each part wherever we see x equal to 0. So this part right here, set it equal to 0. Because it has an x. This part right here, set it equal to 0. This part right here, set it equal to 0. And then all you're doing is solving for x. All right, so x equals 0 has a multiplicity of 2 because it has an exponent of 2. All right, and then we have comma, positive 2 and negative 3 over 2. Those are our zeros. Okay. Our y-intercept's nice and easy. If you plug in 0 for all of your x's, your x-intercept is also 0, 0. Now you should see a nice little common recurrence. If one of your roots is 0, that means your y-intercept is 0, 0. All right, so we have a leading coefficient that is positive. The degree is 4. It is even, so that means that it's going to end up. Okay, and then what do we have here? As x approaches negative infinity, f of x approaches positive infinity. And then as x approaches positive infinity, f of x approaches positive infinity. All right, looks good. So here we have negative 3/2, that's 1.5. We have 0, and then we have 2 somewhere over here. So again, it's still a sketch. If you have multiple points on one side, please label it. All right, so we're going to go ahead. It ends up. I'm just going to do it in pink so you guys see it. All right, so it goes through negative 3/2 because there's no multiplicity. All right, it goes to 0, but it bounces off 0 because it has a multiplicity of 2. And then it has to go back up to go through x equals 2. And there is your beautiful graph. Nice. There's going to be a part 2 for the second page for a couple of the factoring and the last section, the 16 to 19. All right.